Good morning. First of all, happy 90th birthday to Kaz. And second, congratulations to Kaz to become a research-intensive university in Kazakhstan. I'm Jiaguo with Mark Wells here at USDA to present a geospatial technology and modeling approach for livestock production assessment in Akmola Oblast in Kazakhstan. This is a group effort. I want to acknowledge the people who are participating in this effort. First of all, it's a project funded by ADB. It relates to the livestock value chain assessment. Second, the team members are from a diverse group, universities, to work together on those issues, including the people from USDA, people from Michigan State University, and more importantly, people from Kaz led by Rector Yesplov, and Gunas is here too. We want to thank all the people who participated in this project. Of course, the project is assisted by people from ADB, Aristana, and Giovanni. And of course, this is also a collaboration with FAO group. So this is a group effort. We want to thank all of them for their participation. Let me start with this slide. On the top left is a land use, land cover map, where you can see that most of the land in Kazakhstan is herbaceous vegetation we call grassland or rangeland. And there are also some agricultural land as well, particularly in the northwest. And the zoom in picture is Akmola Oblast, and Nur-Sultan is right in the middle there with the color of red. And you can see that there is a diverse of land use and land cover, but the majority is still rangeland and agriculture. There are a lot of rangelands in Kazakhstan, but how can we make rangelands productive and feature the economic development? There are a lot of things can be done to improve the rangeland production there. You can see that management of rangeland is very challenging in Kazakhstan. And the question is, what is the rangeland carrying capacity or stocking rate in Kazakhstan? We want to know the information so that we can properly manage the rangeland ecosystem. And how can the rangelands be sustainably managed to achieve food security or economic development? So those are the broad questions that we tend to answer. But in this talk, and also in the context of this project, we specifically answer the first question, focusing on the Akmola Oblast. Our approach is to use advanced geospatial technologies, data, and information. Then use the data from satellites, from geospatial databases to run ecological models that features the number of animals that we can put or stocking rate of rangeland. Then we provide that to the ranchers or decision makers in Kazakhstan to assess their rangeland potentials. We start from the beginning on the ground. This is Kazakhstan, and we have a team to do a field sampling to collect data that are necessary to run the ecological models. So we collect information on vegetation, soils, climate, and other information so that we can scale up the analysis to a larger scale using drone-based or aircraft-based remote sensing data. Then we will scale up further using satellite data to estimate the whole national or whole country's rangeland carrying capacity. So that's our approach. And we want to start from the bottom up. On the ground, as I said, we collect vegetation, soil, water, etc. And then we develop model and then we assess the entire country's rangeland stocking rate. And we provide that to Kazakh's government and other decision makers so that they can use the information for sustainable management of the rangeland. Step one, before we start the field collection, we conduct a workshop to train the trainers so that they will be the major forces in collecting data and analyzing data and provide the information to develop and validate the ecological models that we are going to use for scaling up. So we conducted workshops. People participated to learn what we called some of the 9-step natural resources conservation service planning process, the principles. So there are 3 phases that we introduced in the training workshop. Phase 1 on the collection and analysis, phase 2 decision support, phase 3 application and evaluation. Those were the principles, the processes that we introduced in the workshop. People learn and then people grasp the concept how to best manage the grassland or the rangeland. Then we go out to the field to collect data. And there is a standard protocol used by USDA, and that involves the certain number of data collection points, and also the plot size and directions, etc. So we use those techniques in alignment with this drone-based images to collect the data. We coordinate those with the satellite. Oh, noisy, sorry for the noise. So anyway, so we have those techniques that we use to collect data at different levels. As you can see, the design of the plot and the way we measure, and then the data we collect. So those are the ground-based data collection efforts that went in last year in 2019 with assistance from now scientists led by Gunas and others. So step 2, we want to analyze the field data to see how we can build a model that can be used to assess the rangeland stocking rate. So using the data we collect on the ground, we establish a relationship between stocking rate and species and information on the vegetation. Here is foliar canopy cover by life form in Acomola Oblast based on the ground data. You can see that here we look at the percentage cover of each species, and the dominant species are the salt grass, as you can see here on the second column here, second row in the data in the table, and then birch grass are also present in the oblast. So you can see that a lot of bare soils meaning that a lot of land being exposed to soil erosion. But we also noticed some litters on the ground, which means that some of the leftovers from previous years that still remain on the ground, undecomposed. That indicates some of the vegetation being left over, ungrazed or unused by animals. So there are certainly things that we can do to improve the ground cover, maybe, or reduce the soil erosion by properly managing the rangeland. Look at the relationship between forage, which is something that animals can consume, and also standing biomass. Here is the relationship between the two. We want to emphasize that standing biomass may not all be consumable by animals, cows, sheep, horses, etc. So if you want to assess the stocking rate, we need to focus on forage. So here is a relationship, and we want to do this because we know that we will be able to collect data on the standing biomass much easier than collecting the forage. Based on the data we collected, we established the model that links number of animals to other variables, physical or biophysical variables. And also we look at their water availability too, so that animals don't travel too far to reach water. So that's another thing. We also look at the slopes so that animals don't have to climb up hills, and that consume energy and of course affect their growth. So those are the things that we collected, and we will be using those in the model to calculate the stocking rate. Step 3, we use geoprocessing and data and models to scale up of the stocking rate that we estimated based on the ground field data, okay? Here is how we approach this with the geospatial technology. We have remote sensing imagery from different sensors. We also have a geospatial data set that include NPP, land use, land cover, information, soil, DEM, climate variables, etc. So we already established the relationship between, I don't know if you can see my cursor, but here is the relationship between the number of animals and other variables we showed you in the previous slide. And this is the environmental factors. So in the geospatial analysis, we focus on the application of the remote sensing geospatial data and environmental variables in the model we established here to assess the pixelized regional stocking rate, okay? So that is what we did at the Oblast over the last year, okay? I'm going to show you some of the data we collected. This is the DEM data. We use DEM data to determine the slope and also animal travel distance, because the distance, as I said earlier, but you can see that Acomola is pretty relatively flat, but you have a high elevation in this part. We focus on we will focus on the Acomola region. Maximum, minimum, and extremes, particularly to see what extreme temperatures you may have in the Akumola compared to the southern part of Kazakhstan. Okay. The reason we want to use data, particularly how long can we put animals in the grasslands or the rangeland. So we can assess the number of days we put animals in the field, and also we will use the temperature to assess how much of the grasses are going to be on the ground before it gets too cold. We use precipitation data to determine water availability, and of course drought, floods, etc., affecting the rangeland productivity. So those data as well in the model. Soil is another one. I think you all know that soil properties are important in determining soil erosion, and that determines the grass density or forage availability. So we use the soil data to determine those information. We can use those information in the modeling effort to determine the stocking rate. Here, we want to show you, as I said in the beginning, the total entire Kazakhstan's land use and land cover. We want to mask out other land use and land cover, focusing on the rangelands. And Akumola is here, as you can see here, those dots. I don't know if you can see them or not, but the dots are the fields or the ranches or farmers that we visited in 2019. And that data allowed us to have a spatial representation of the Akumola Oblast. We obtained the data on water, the water occurrence to determine water accessibility. So basically the idea is to see how much water is available in Kazakhstan or in Akumola Oblast. And then we can determine whether or not animals can reach to. Here is based on the geospatial analysis, the information we determine to what we call the travel distance. So if an animal is placed in here, for example, the animal would have challenging in reaching water because this is what we call high. That means the distance, the almost 8 kilometers animals have to travel in order to get some water. So that's where we want to assess the suitability of the environment for grazing. So given the distance travels, that will we will calculate the stocking rate, because the more distance an animal can travel, the less stocking rate you would have. Some areas around along the corridors are much easier for animals to get water, but other places are difficult for animals to get water. So that changes the equation for calculate rate. Some of the preliminary results will show you, on the stocking rate. First of all, we looked at the total, net primary productivity, which is a part of the equation that we developed. And this is the maximum value of the NPP, annual NPP, and this is the mean value, and here is minimum value. Okay, so you can see that some areas are going to be much vegetated than others. Particularly, you can see here we are focusing on the rangeland here. Okay, so based on the annual net primary productivity, we calculate the standing biomass, and here is maximum values of standing biomass this is the, taking the maximum value from the year 2000 to 2004. And this is the mean value of the standing biomass. And here is the minimum value of standing biomass, okay? You can see again the spatial variability, but those variables or those net primary productivities can be or have been calculated by using satellite imagery. And stocking rate for Acomola oblast, and here we show this number of hectares per cow. That means if you want to raise one cow, what is the total number of acres of land you need? You can see majority of the stocking rate here is in this range between 1 and 3, about 1 and 3. But you also see other spots, okay, other isolated areas where you need a larger land or larger area of land in order to raise one cow. So, and here you see on this side towards the southwest, you have a little bit lower density stocking rate than here. And here is probably we call it hot spots, the areas that you probably should consider not to graze, but focusing on the green area might be a good idea. And this stocking rate was for 2000 and 2004, and we did the similar analysis. So you can see the areas, but then because the weather changes, because of the climate differences, you see that this part is much worse than this area. So you can see that even from year to year, the stocking rate could be different, meaning that climate, the weather could affect the stocking rate. We did one for 2019, and you can see we use what we called optimal, less optimal, or marginal, etc., to indicate, where we can, what we recommend, or where the area, where is more optimal to graze animals. And again, here is cow, for each cow, how much land is needed. Again, you see here, most optimal grazing land are in this area, and here is less optimal than here. So that gives you some ideas of how the Acomola oblast stocking rate looks like. And the information can and will be available where to farmers, to decision makers, to ministries, to any other publics, where they can zoom into their field to assess their stocking rate. So here, in this project, we provide a whole perspective of the entire oblast. Again, we can zoom into individual field and assess individual farms' stocking rate if that's desired. So in conclusion, the geospatial technologies and data information we provided through satellite imageries, geospatial analysis processes can provide important information to, in the rangeland assessment, particularly on the stocking rate. And models developed based on the field data can be scaled up using geospatial tools that, we worked in oblast, but we can definitely scale up to other oblasts or the entire Kazakh national region. There is a gradient for the Acomola. There is a gradient in stocking rate, as you can see, that spatial gradient from southwest to northeast. So that provide information for decision makers, maybe oblast level decision makers, to assess where they can, set priorities for rangeland, development. And you can also see that, overall, it's about 1.6 to 3 hectares per cow in Okamola Oblast. That is general, assessment of the stocking rate in the region. Of course, some areas are better than others. Then if you want to look at a specific farm or ranch, we need to focus and we need to zoom in to that particular farm to get the exact number of the stocking rate. I want to thank you for the opportunities for us to present the research project, and also want to acknowledge ADB, CASNOW, FAO, and others to collaborate with us to make this a interesting and also important project. Thank you very much for your attention. And if there are any questions, I believe we can answer those offline or send the emails to Gunas or others so that we can get your questions addressed. Thank you again.